Okay, good. Shall we begin? I only got one homework. Radu, I know that you did not have time
We are lazy.
for it.
Good developers are lazy developers. Are lazy people.
Yeah, but this is a DevOps course, not a developer course.
Yeah, that's why I told you I'm sorry. I didn't do more. I'll,
Yeah,
I'll do it next time more.
yeah, I also plan to catch up this weekend with homework.
Okay, next homework will be based on the today homework. So, okay, I will not share my screen because you already have all the information into the GitHub repository. I have posted it earlier this week. So you can take it from there. Today we were talking about Kubernetes networking and services. And what is a Kubernetes service? It is Kubernetes has abstract access to a group of pods and ensures reliable communication despite the dynamic nature of the pod IP address. Kubernetes also supports what that means. It For example, if you have different one service running on multiple pods, in a normal way, you cannot access directly each service and therefore each pod, so that you cannot spread the load between the pods. And this is where the service comes into place. The service is a central endpoint in Kubernetes that would load balance the request through the pods that matches a certain match label. And there are multiple different type of services in Kubernetes. The first and the default service type is cluster IP. And cluster IP is exposing the service only within the Kubernetes cluster. This is as I already told you, this is the default service type. The use case of the cluster IP service is internal communication between microservices. And let me share my screen. And create some services. So I get pods. As you can see, I already have whatever we did last week. And kubectl edit get deployment. kubectl, let's get deployment example deployment minus of YAML. So we are getting the manifest of the deployment and we are outputting as a YAML. We can output it also as a JSON, but from my point of view, YAML is easier to read for humans than JSON. And here I can see that we are using the match labels app equal nginx. And okay, we are creating the first file. As I explained last week, every object in Kubernetes starts with API version and kind. So we run kind. This time will be service, metadata, name, example, service, yes, example, deployment service. We are not going to write the namespace because we are using the default namespace. So we are adding spec selector, and this is where we are using the match labels. Let me see if I can open DevOps course 3. Oh, can you see it? Shall I make it bigger?
Maybe
Yes,
it's like
make it bigger.
Yeah.
Is it better? Okay, so we have the match label, selector match labels. It should be in the service in the selector. And in here we put app nginx. This is how the Kubernetes is matches a service to a certain deployment or stateful set or daemon set or simple pod by using the labels. Okay, and then we put ports. Protocol is TCP port. In this case, we use container port 80. But this port, the port is what port we'll be using for the to access the service. And target port is what is the port that the container is listening on. Is this? These two doesn't have to be the same. They can differ. And type cluster IP. Okay, saved it, and now kubectl get SVC. This is how we list the services, or kubectl get services, the same output. kubectl apply -f cluster IP service, and service was created. And as you can see, we have created the service, and the Kubernetes has assigned one IP address to it, and is listening on port 80. Now, what happened? Nothing. Now, as I mentioned, this service can only be accessed from within the Kubernetes. And how do we, let's use this pod.yaml or get pods, this example pod, extract PI, we are inside, and curl HTTP example deployment service. And it gives us yeah, it's okay. I think it gives us the deployment service Nginx page. Now, by default, if you don't put anything, you just put the service name, it will try to access the service inside the same namespace as the pod where you wanted to access it from. But if you want to be sure and you want more control over it, you can put the namespace name .svc and it will give the same output. It is just SVC is the service, the default is the deployment name, and this is if you want to, you can use the whole URL cluster.local. This doesn't seem to give. Maybe it's not matching the. This is interesting. Okay. Anyways, this should be the same as the one without cluster.local. Sometime by default, the Kubernetes every Kubernetes cluster is coming up with is starting with cluster.local domain, but it's not necessarily true. It is configurable at the initialization of the cluster. So this can be something different. And can be, I don't know, a real domain name if you really want to put the cluster on the domain name. The next service type is node port, and its functionality is exposes the service on a static port on each node in the cluster, allowing external access through node IP slash column node port, a port. Node port. YAML. It pretty much looks like the same as the cluster IP service. Only the difference is that the type is not port instead of cluster IP. And let's apply it. And as you can see, things is a bit different because in here you don't have one port anymore. Let me change this one so that we and apply it so that we can okay, here is the cluster IP, here is the node port. As you can see, the cluster IP only shows you the port that the service can be accessed on, while the node port IP has this strange high port that it is showing. And what this does is the Kubernetes is making a port forward from port 80 to this high port on each node into the Kubernetes cluster. Get nodes minus provide. Let's see, get IP of one port and this high port. Yeah. Docker accept kind worker. And because this is running on the Docker, and we did not added any kind of configuration to expose this port from the Docker container into the local container, I have to exec into one of the Docker nodes and try to access it like that. And we're still giving this. Yeah. Apparently it needs the protocol. So as you can see, it exposes the Nginx access to the network via a random high port. This random high port is not actually that random. It is starting from 33,000 and goes, I don't think, 2 or 3,000 ports that are allowed. It is also configurable while we are initializing the Kubernetes cluster. The next service type is a load balancer. And because we are running kind, and the load balancer kind of service is provisions an external load balancer into the cloud provider to route external traffic into services. And this is where I ask both of you or all of you to use kind if possible, because kind fix.case.io created this kind cloud provider application that I have it in here, and I have to start it like this. And what this application will do, yeah, it will make the Kubernetes our node work as a cloud provider. And let's copy this again, because the service type will be almost the same. Vim balancer service.yaml. Let's rename it so that we don't overwrite b dash. And instead of cluster IP, we are using load balancer type of service. And we apply it. Okay. Util get svc. And it did not, as you can see, it has deployed the load balancer type of service. What is the difference? It has an external IP. And if you are you are taking a in-depth look, this IP address is in the same network as the node IP address. But I think that if everything goes fine, apparently it doesn't. The service should should make some routes so that we can On Mac, I have sometimes this problem that it doesn't always work. If you are doing it on Linux, it will always work. So there is if you will try it at home, this will be working. Basically, you will be able to access the service on this port. We can do the exact same thing as we did with the node type, only that this type you'll be using the load balancer IP, and as you can see, we got the same Nginx page. The next one it is external name, and what the external name does is maps a service to an external DNS name. This service does not provide proxy traffic, but only resolve a DNS name into a Kubernetes specific host name, which external name.yaml. It also starts with API version. Find service lowercase. Good internal. What it does, it is translating google.com into google.internal, so that if, for example, you have in cloud database that is running in RDS, for example, in AWS, let's say. The AWS will give you a very long random domain name for that database. And to make it more user-friendly, you can just translate it like this to a shortened version and internal naming. And then you can reference reference the database using the service name. These are the built-in services. Now we have a few more other Kubernetes service types, and that would expose Kubernetes services to the external in different ways. And the first one is an ingress type of service. Now, the ingress type of service, it provides HTTP or HTTPS routing service offering advanced features like SSL termination, domain-based routing, path-based routing, and others. But they need a controller to be installed. And since I did not show you how to install things on Kubernetes, maybe I should have started with that. I will just give you an example and in theory, and we'll work on those later on. Basically, the controller can be an Nginx controller or traffic, Istio. I'm using HA proxy quite a lot because I like HA proxy and I'm very familiar with it. And let's see, API version, networking.ts.io. The good thing is that the manifest for the ingress, it doesn't matter which controller you're using, it is the same. Maybe some annotations, the difference are on some annotations, which provides different configuration depending on what controller you're using. This will be a ingress class name. This can be Nginx, HA, proxy. It is configurable, whatever name you want to use in the controller. And then it has rules. For example, host example.com. And then HTTP. If you want to configure some paths, then we add path-app1. Path type, prefix. This can be regex. And then we configure the backend type, and let's say it's F1 service. This would point to a cluster IP service in the Kubernetes service. Port number 80, for example. Let's say we want to use this one, then we can change it. Yeah, we can also add, let's say we have a certificate. And in Kubernetes, the certificates are stored in a secret. And the name of the secret where the certificate it will be stored in. And this will provide HTTPS service, and it will expose your application into the Kubernetes, into the world, using HTTPS, using the domain that you have configured in here. Now, the secrets can be either stored in a vault, or Kubernetes have this option to expand the API that I have told you last week about, and we can deploy Cert Manager CRD, for example. And Cert Manager can handle the certificate. It works pretty good with most of the major DNS providers. And the good thing about Cert Manager is that you don't have to bother with the certificate anymore, because whenever it is time for the certificate to be renewed, it will issue a renew request, and it will automatically renew the certificate. One second, let's see what kind of measure.
Does it also work with self-sign certificates?
Yes, it works with self-signed certificates. If you go to my blog, I think one of the last posts, it is one example with the self-signed certificate in there. So you can just look it up and look how it works. Okay, I will not deploy this one. It was just an example, because obviously we don't have a controller deployed. And without a controller, this does nothing. But just for you to know, the controller is working with a load balancer type of certificate, so it will have some services. Actually, the controller is a proxy that does the proxying between the public URL and your pod in the backend, just like Nginx work or HA proxy. Whoever knows how. Do any of you is in here does not know how Nginx or HA proxy or transparent proxy work? Okay, then I'm assuming that all of you knows it. Okay. Next is the Gateway API, and the Gateway API is a modern standard designed to replace the Ingress API, and it provides greater flexibility and extensibility for managing traffic routing in Kubernetes. This service type is not even a year old in Kubernetes. The key features of the Gateway API is protocol supports. It handles HTTP, HTTPS, TCP, and UDP traffic, unlike the Ingress that only supports HTTP and HTTPS traffic. It also has a separation of concerns, which decouples the infrastructures, the gateway, from the routing rules. Therefore, um, for example, the DevOps people, guys, you create the gateways and you tell to the operations or the developers, okay, for your application, for the web application, use this gateway, and then whenever they want to expose something, they create the object that would work with that gateway and would route the traffic according to where it is needed to go. It has advanced features like extensible routing, support for custom controllers, and multi-team collaboration because of the decoupling of infrastructure from the routing rules. The Gateway API has three main control components. The first one is the Gateway class. Gateway network inbox. This Gateway API is not yet in stable release, but it is good enough. Actually, in Kubernetes, there are a lot of API versions that are not stable, but everyone is using them, so it's safe to be used. The, and this controller name is, it depends very much on what kind of gateway API you're using. I am mostly familiar with Envoy Gateway and Cilium Gateway. Cilium Gateway in here, it has Cilium. Envoy Gateway, it has some other things in here. Now, after you have set up the Gateway API, you need to create the gateway. The kind is gateway. Kind is always with lowercase. And in here we can say, okay, HTTP gateway, for example. In here in the spec, we mentioned gateway class name, which we created earlier. And we are setting up the listeners. Set protocol, HTTP, port 80, name, and you can set HTTP. And so on. There are a lot of things that you can set up in here. You can look up Gateway API Kubernetes, and you have the full documentation there. As I said, it is still a very new way of exposing the Kubernetes. So there are a lot of things that are still changing and changes from one version to another. So it is always better to look into the documentation, because whatever I say now in here might not be available in 1 month from now or half a year from now. And these parts are created usually by DevOps or the people that are handling the architecture. And after we have created the gateway class and the gateway, we can create the routes. And the routes can be HTTP routes, TCP routes, UDP routes, whatever. And the good thing is that, let's say you talk with the developer and the developer say, okay, I need to listen on port 2580 and 443, and you will be the one that sets up, and then the developer will only use those ports and make the routes. We want beta 1, and HTTP route, metadata, name, you can set whatever, example from route, spec, parent, res. In here you reference the gateway that you are get gateways.yaml. Rules, matches, and this the backend reference, which again they will be pointing to a service name, cluster IP service name in the port. In the Kubernetes cluster. And again, I will not deploy this because for this I would need to have a gateway controller deployed, but I don't have it. So I'm just creating this in here. So what is the comparison between the ingress and gateway API? Basically, the gateway API features multiple resources, gateway routes, everything that can be handled by different team. In the ingress, everything is done with a single resource. The gateway API supports multiple protocols, not only HTTP and HTTPS as ingress does, but also TCP, UDP, gRPC, and others. The ingress controller has a limited customization via annotation, while the gateway API is highly extensible with controller supports. Okay, so this is pretty much all I had with services. Do you guys have any questions? If, let's say, someone asks you what is the difference between cluster IP and node port, can you tell them what it is? No?
For cluster IP, you can expose a service just inside the Kubernetes cluster.
Yeah, as its name says, the cluster IP is a service that only works inside the cluster. And node port, as its name says, it exposes the port, the service, the port into a high port on the nodes. Okay, homework. Besides the web server you have done for this week, I want you to create a service for it and expose the service to the external network. Now, as not everyone is using kind. The load balancer service can be done with one service type that is called Metal LB. This was created for pretty much clusters that are running in bare metal, but it works with kind, it works with Minikube, it works with microcates. All of those works. All of those can use it. You can just search on Google for Metal LB. I also have a blog post on that. So if you want easy read, you can also look at that. As I said, give this cloud stuff, cloud provider kind a try, because it worked for me. On my Linux laptop, it has an Arch Linux and it always worked. Does any of you use anything else than Linux? No? Okay, let me ask you something else. Does anyone that is not using Linux for day-to-day test?
I use also Windows for several tasks.
I think that in Windows, if you deploy Linux subsystems for Windows,
AWS, right?
yes, that would work with it without any problem. Okay, any questions? If not, we can close it for today. No questions?
No.
Okay, then have fun, and I hope that you learn something today.
We'll see after the homework.
And see you next week. Next week we will talk about how to deploy stuff in Kubernetes. So starting next week, we will deploy multiple applications, start deploying multiple applications, and we will see how things are working together into Kubernetes cluster. Have fun and have a great weekend. Bye.
Thank you. Bye.
Thank you. Bye.